Okay, we're started. We're going to try an example of the control systems optimization. So here we have the Canvas page, and we're going to go to Files, Scilab, Code and Examples, PID Design Optimization, and we're just going to download these three files. We're going to go to the desktop, and I've made a little folder called Demo, which doesn't have anything in it. So we're going to save OptiGain 7. We're going to save Setup 2017 example, and we're going to save stepperf.sce all in the same folder. Now we're going to close our browser. Close this. We're going to navigate to the demo folder, and we have, we'll ignore that. I'm going to actually move it to the trash. There we go. Okay, this is what your folder should look like. And here's an example. So we're going to just, all you have to do is, assuming that Scilab is installed, just double click this. Scilab should start up. Okay, so here's our Scilab console. And then over here is our script. And what I want you to do is that this is a template for you to use on any problem. And so we're going to save as in order to reuse that template. So I'll save as the video example. All right, so we've renamed that. Now let's change our plant a little bit just for fun. So we have these poles. I'm going to make them 1.2, well, a little slower, not faster, so 0.5. And the same 0, and then we have our denominator and numerator, so that's the same. We'll change our spec. Since the plant is a little slower, we'll make our spec a little slower. Say our percent overshoot is also 10%, and we'll put this down to about 200. I know that that's where it's kind of coming out. So now we're going to start off with a pretty big, well, with a small n number of values so that this thing can go fast. And maybe that these are our three starting values for KP, KI, and KD. But we're going to kind of search a bigger range. So let's spread it out a little more with a range of 10. So for example, KP is going to go up to 210 and down to 2.1. And that's it. Now we just save it and run it. Oops, I made a mistake. Okay, so I think this actually isn't needed. We're going to comment this out. And it's wrong for this program anyway. I think since we clicked on a file in that folder, it's going to all be right. Yes, in fact, this shows us that we're already in the right place. So save and execute. Except, oh, yes, sorry, one more comment. All right, so we don't need that if we set it up just as I said before. So now here is our progress bar and the estimated time. This is only approximate. It's probably going to get done a little faster. It's over halfway done right now. When it finishes, it automatically plots the results. And these are the different results it found. These are rather different because we're searching a very large space and the accuracy might be kind of low. So sorry, I didn't mean to expand that. So we have lots and lots of graphics windows. Let's start with number 1. this is the best thing it found in terms of settling time. We had a spec of 1 second. That looks, that point is 5%. So this is, and we can see the exact settling time that was achieved, 1.02. So that's not quite 1 sec, but it's surely quite close. I'm going to get rid of that so we can see more. Okay, and then window number 2, if we can find it, is the overshoot spec. This one looks a little odd, and it probably means that there's a lot of control effort, and I just sort of know what these, this looks like a whale, it has a lot of control effort. So indeed that one's about 600, which is kind of high. And it doesn't, it looks a little, first of all, its settling time is horrible. So right there we have to reject this one, 2.8 settling time. So I'm just going to close that. This one I'm going to keep around because it's not horrible. It's got an overshoot of 17% right here. That's a little too much, but it's not a really horrible one. Now this SSE one, it really gets solid and settles down perfectly. Its settling time is great, 0.6. And what's wrong with it? Well, it has a very high control effort as well, 500. So plus a high overshoot. So, but it's something reasonable. I'm going to close it though. Then we have control effort. So this one is going to take its time and be slow because it's saving control effort. So the control effort for this was only 75. That's very low compared to 200. But its settling time is even worse. Its overshoot is horrible. This is no good. So what are we left with? We're left with number 1, and where's our balanced one? Balanced. So balanced is really bad too. This is not settling at all, and it has a huge overshoot. So forget about balanced. This is the best we've got so far. So what we're going to do is say, okay, this one's the best. And what we're going to do is say, well, okay, this is our new starting point, 26.5, 11.0, and 5.0. And so we'll go back in here and put those gains in. They're not that different, but it's the best we've got. 26, I guess I'll go ahead and make it 26.5. Then the next one is 11.6 for Ki, and 5 for KD. And then the reason we had so many bad ones is because our scale range here is so long, so wide. So we're going to narrow this down a lot. And like in our earlier file, we're going to go 1.5. So we'll optimize this. Let's take a few more values as well in that small range and just let it go a little longer. Well, let's go to 13, 14. So that's, remember this is cubed, so when we figure out how many total points are visited. So now we're going to save and execute. Now it's estimating 2.7 minutes, and so I'm going to pause the video recording. Somehow.